Alright, hey guys, this is Mrs. Gebhardt, and with Mr. Mahoney, who's not going to be present at this time, but Mrs. Adari as well, we decided to do some filming a little differently so you can actually see us, and we'll take through the notes just like we've been doing previous to that. So just like in every other notes presentation, we have our essential questions. So number one, what causes ocean currents and tides? And then number two, how do currents distribute the heat around the globe? And make sure if you are going through these notes and you can't answer these, that you go back through and do what you need to do.
What is an ocean current? Currents are mass of moving water. And if we can take a closer look at this diagram, you can see that hot water, it is moving away from equator to the northern part. And then cold water is moving, it's coming from the northern part, coming to the warmer areas.
And we have to consider when we think about the warm and the cold, we know that cold water is denser. So it makes sense that we're going to have cold water here and the warm water is less dense. So it's going to be able to rise up here, and as we get colder, it's going to sink because the water is going to get colder. So it kind of makes sense that that's how it works itself out.
Okay, now let's talk about surface currents. What are surface currents? Result from strong winds blowing over the water. We're going to see the diagram on the next slide. As you can see, the area on the red, all of these are surface currents moving away as a cause of the wind.
Go on to deep currents, okay? Deep ocean currents are going to be driven by density. That's the biggest thing right there. And the water we can expect to be more dense if it's cold, okay? As well as if there's an increase in salinity. So where there's a lot of salt, that water is going to be dense. The densest water on this planet is going to be found in the polar regions, and that makes a ton of sense because it's cool. Now I'm going to show you a diagram, and that's on the next slide. And this is just, again, it's a conveyor belt idea, but this is going through how the deep ocean currents function. Same kind of current action that you got from the other diagrams. So we can expect warm here, which is the red. As it comes up to the polar regions, it's going to get cold, it's going to sink, it's going to get more dense, it's going to fall. And it just kind of continues to do this cycle pattern.
Okay, now we're going to talk about downwelling and upwelling. Downwelling is the movement of water from surface to greater depths, carries away the oxygen into the deep. Now the upwelling is the movement of water from the deep sea to the surface, which brings up the nutrients. Now I'm going to talk to the next slide. We can look at the diagrams. As you can see, the downwelling because the water from the surface sinks down, and the up, which brings the oxygen down into the deep sea, and then upwelling is the water movement from deep sea into the surface, which brings up the nutrients.
Let's start thinking about what a wave is, okay? So we've all been at the beach, or you've been somewhere, even a wave pool, and you know it's that up and down motion when you're sitting in there and you're going up and down. That's the motion, that's what, from the surface, that's what causes a wave. That is the wave, okay? Caused by winds. Understand that waves don't move water. They're moving energy. They're generating energy and pushing it. That's why if you've ever been smacked by a wave, you've actually been smacked by the wave. You're hitting the energy. All right, so we're going to talk about some of the things that cause a wave. All right, so earthquakes, landslides, any kind of, like if this earthquake broke the earth open. This is actually a volcanic eruption that happened underwater, and this just tells you the intensity of the volcanic eruption. But any of these events can cause a wave, which is a ripple. And then, if you all are familiar, we've probably seen landslides, where the earth was up here at some point in time, and it moved, hits the water, which is right down here, and that can cause the waves to then form. So these can lead to big waves, and you've probably heard of them. Those are the tsunamis that you may be familiar with. All right, so the shape of a wave, and I'm sure you all are familiar with it, you've seen this before, but we've seen this general shape, okay? So the wave height is going to be from the trough to the crest, all right, and that's up here. The wavelength is going to be from the crest of one wave to the crest of another wave. The trough is the lowest point of the wave, and the crest is the highest point. Now we know with waves that this distance here can be closer together, it can be further apart. This can be closer together or further apart. It really just depends on the conditions at the time.
Now let's take a look. What is an undertow? The pullback of water as it runs back to the sea. If you've ever been to the beach and then the wave had hit your back, and that is the energy that the wave length is hitting.
And we can see it when we think about it. If you've ever been there, like you can imagine if you're a little floaty here, you're continuing to be pulled that way. And you've all probably felt the pull. It changes depending on the not temperature, but the weather conditions. But that's what it is. That's where it can be dangerous, because if you're just chilling out here on your little life raft with your little rubber ducky, you could end up deep at sea, okay? If you woke up and realized that there are sharks swimming around you, so.
Hey, what is a longshore current? Have you ever been to the beach and then you're staying right at the shore? You're lining up with your mom and dad, and after time passes, you end up moving away from your mom and dad. That is just because of the longshore currents. Okay, the sandbars are created because of the longshore currents and waves. So the deposits of sands into the shore. We can move to the next diagram, and then you can see the sandbar creating on the deep of the sea.
So, a very dangerous thing that actually can happen at the beach is called a rip current, all right? And essentially, what happens is, okay, so we've got these sandbars, and let me see, I got a little marker here. So we have these sandbars that are forming all along here, okay? And we can imagine this is the beach, okay? And here's our waves, okay? And what happens is these waves come in at such an intense angle that they actually sort of poke a hole right in the sandbar. And when they do that, it actually has, and this sounds really gross, but it has a toilet bowl effect. It's just like you flush the toilet, and it literally is going to suck you out to sea. Okay, and so the danger obviously is that if you're out here, you can end up out here struggling and struggling and struggling because this current is so intense that it's pulling you out to sea. Now, sometimes what you will see at the beach, and look at the next slide. I'm going to click the next slide. What we can sometimes see is, like, you may see these at the beach or whatever, kind of putting out there. This is the current. It's going to rip you out here, rip current, okay? And how to get out of the rip is you have to break the grip of the rip. So you have to actually swim out of it like this and be parallel to shore. Because a lot of times, even the best of swimmers, if you're caught in a really bad rip current, you can drown because it's that intense.
Okay, I guess you're all familiar with tides. It is the tide, the rise and the fall of the sea level, and this is because of the sun's and moon's gravity. Remember, after watching this video, you should be able to answer the essential questions. What causes ocean currents and tides? How do currents distribute heat around the globe? Now, if you are not able to answer those questions, make sure you go back and rewatch the video. And if you have any question, bring it to the teacher the next day.